All right, hi guys. This is your video for Geometry SLO Review Worksheet number 5, Triangle Similarity. Again, I've got a couple problems directly from the worksheet that we're going to talk about, and hopefully this will help you kind of refresh your memory as to what you need. All right, our directions for the first one that we're going to do, we're actually going to do problem number 2. Okay, so state if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. Please remember, we got to remember that similarity, there were 3 ways to do that. We had angle-angle similarity, where we proved that 2 angles were congruent in the 2 separate triangles. We had side-side-side similarity, where we said, hey, guess what? All 3 sets of sides, corresponding sides, are in proportion, not congruent, but in proportion. And then we had side-angle-side similarity, where we had 1 pair of angles that was congruent and then 2 pair of corresponding sides that were in proportion. And it looks like if we're looking at this, that's what we're going to go with. Now, we need to double check. First of all, we've got 2 angles that are congruent. We've got angle R congruent to angle E, right? And so that takes care of the angles, right? We like to write the A on there so we know what we've got. Now I also look and see that I've got 2 pair of sides that are hopefully corresponding and may be in proportion. So what we have to do is we're going to take, and here's the trick to always remember. If you're not sure what side goes with what side, try to match up your smallest numbers. My smallest number in this first triangle is the 60 that I just underlined. If I look over here in my bottom triangle, I've got 108, which is the smallest number. So when I set up my proportion, I'm going to do 60 over 108 because I did smallest side over smallest side. Now my question is, does that equal? Notice how I'm writing my question mark because I'm not sure if it's equal. Does that equal? And then I go and I look, all right, this is my longer side in the triangle for RST, and then over in this triangle for EFG, it is 126. So does 60 over 108 equal 70 over 126? All right, now there are a couple ways to actually look at this. I can, if I want to, I can take each fraction individually. Okay, I can take each fraction individually and reduce it and see if I get the same fraction when I've reduced. Or if I'd like to, remember how to check that if 2 ratios are in proportion, you can cross multiply, and if you get the same thing on both sides, then your 2 ratios are in proportion. Your 2 fractions are in proportion. So when I do 60 times 126, I will get, oh goodness, I know I had it. Oh, there it is. I will get 7560. All right. Does that equal? And again, I'm going to put my question mark at the top line to see if it equals. All right, and then when I do this over here, I did 60 times 106, and then I will do 70 times 108. All right, when I do 70 times 108, I get a 7560 again. So that does equal, and so what I'm going to have then is triangle EFG is similar to triangle RST. All right, and if you notice, I went E to F to G. So I went down the longer side first. So I start here up at the R, I go down the longest side first, R to S to T. Okay, so EFG, similar to triangle RST, and it's by side angle side similarity. Okay, so that's how you work through that one. Now, if we take a look at a problem on the back, let's go to the back. Oops. Okay. Let's go to the back of our page. And if we're looking at this, this is number 8, okay? And so we are going to solve for x. The triangles in each pair are similar, okay? So we don't have to figure out if they are similar. We already know that triangle LUT is similar to triangle LNM, okay? So we're already told that they're similar, so all we have to do now is solve for x. If you take a look, if we're taking a look, we've got quite a bit of information. Okay, we've got bottom sides, we've got actual just plain old sides, and what we can do is we can take LU, all right, we can take that 2x minus 9, so the shorter side over the longer side. If you want LN, we can put it over 21. Because the triangles are similar, the 2x minus 9 over the 21, LU over LN has to equal, we go over here, it has to equal LT, so 9 over, we'll go green for that one, m. Okay, so 27. Okay, just make sure that you're grabbing the right numbers when you do that. And of course, you are going to cross multiply. Okay, when you cross multiply, please, please, please be careful. This 2x minus 9 needs to be in parentheses. So when you cross multiply, you're going to do 27 times 2x minus 9 in parentheses, and you will distribute. I can't tell you how many times you guys have missed points on problems because you forget to distribute properly. So then on the other side, we're going to do 9 times a 21. When we do the 9 times a 21, we get a 189. Okay, and when we distribute over here, 27 times 2x is a 54x, and then 27 times the 9 is going to be a 243. Okay, simple algebra from here on out, add 243 to both sides. Okay, so 54x equals 432, and divide both sides by 54, so x equals 8. Okay, that's your answer for that one.